Let's look at the first example that we've already done and do it all over again, but this time instead of using p-values like we did before, let's use rejection regions. Again, notice we have the exact same information, the exact same claim, so we're still going to look at testing the claim that the mean is less than 5.4. That means that we're looking at the mean being less than 5.4 is our claim. Because there's no equal to, that means that will land as our alternative hypothesis just like before. Just like before, notice it's our alternative hypothesis. Then the null hypothesis will be the complement, which is greater than or equal to. Just like before, we still do have that they gave us the population standard deviation sigma, so we'll still be doing a z-test, and we'll still be using z's, so we'll have a z-test. So just like before, we'll do a z-test in our calculator using the stats button. We'll enter in the exact same information. Let's see, the mean from our claim was 5.4. That comes first. Then the population standard deviation was 0.54. The sample mean given in the problem was 5.23, just like before, and the n was 50. And the alternative hypothesis, which tells us whether or not we have a left-tailed, right-tailed, or two-tailed test, was a less than, which tells us we have a left-tailed test. Last time, we cared about the p-value because that's what method we were using was the p-values approach. Now we're going to look at doing a rejection region. So we care about the z-value here. Well, the z-value we get out here is negative 2.23 if we round it out to 2 decimal places. So this is what's called our test statistic. So that's the thing we need to test to see if it falls inside of our rejection region. Well, we need to come up with our rejection region. Well, because it's left-tailed, you can draw a picture of our normal graph that is left-tailed. That means that our alpha should be whatever the area in the tail is. Well, the alpha given in the problem was 0.01. So that's going to be the area in that left tail. So, working backwards, how do we find the z-value that's going to create that alpha, that area of 0.01? So this is our picture for our rejection region. Well, the only way to find a z-value when we have an area is if we use the inverse norm function in our calculator, or we use the normal distribution table. But let's use the inverse norm function. So we'll do inverse norm of the area. Remember, it's already an area to the left, so we can just go ahead and plug it right in. So we'll plug in 0.01, and we get a z-value of, let's see, what did we get? Negative 2.23. That is the value that makes up our rejection region. So I can fill that in on my picture, negative 2.33. Okay, now I need to use this rejection region that I just drew up and my test statistic and see where the test statistic lands on my new picture. Well, notice our test statistic from our calculator came out as 2.23. This is the value from your calculator. The value that we just came up with for our rejection region using our alpha and our inverse norm of 0.01 was negative 2.33. So notice the test statistic is not in the rejection region. So if it does not fall in the rejection region, that means we're going to fail to reject H naught. What does that mean? Well, remember, H1 was our claim, which is that the mean mu is less than 5.4. That was our claim. And our H0 was that the mean mu was greater than or equal to 5.4. So again, just like before, if we're failing to reject H0, then what are we doing with the alternative, the claim here? Well, then we're going to do the opposite. We're going to fail to accept. Well, if we're going to fail to accept our claim, let's translate. What does that mean? Failing to means there's not enough evidence. This test was inconclusive. What are we doing here? We are failing to accept. So we're going to say that there is insufficient evidence to accept the claim that the mean is less than 5.4, because we're failing to accept. And that's our fancy answer that we will give. Now, sometimes they will give us really specific terminology, and you may also hear the word critical value thrown around, or critical values. That's just a fancy term for the values that create a rejection region. So these could be T's or Z's. Either way, they create our rejection region. Just in case you ever hear that terminology.